This example demonstrates how to create a Simulink model for using FiO Std Evaluation Board as a target to acquire real-time data from two sources, including 1. A potentiometer and 2. An on-chip temperature sensor. Both analog inputs will be sampled and converted to digital values by an on-chip 12 bits analog to digital converter set at 100 Hz sampling rate. The converted data will be sent to the host PC via USB Human Interface Device Protocol. The host PC will receive the data, convert the measured temperature from volts to Celsius, and finally displays both data in real time in Simulink simulation as numerical values as well as time series plots. Before we can begin creating a Simulink model, it is important that we configure FiO Std Evaluation Board as shown so that it can communicate with the host PC. Important points to note are as follows. Jumper J5 must be set to USB that's in low position to allow us to use USB as power source for the board. Jumper J3 must be set to the right. This enables USB data lines. Jumper J1 must be both connected. This connects the USB data lines. Jumper J9 must be set to high. That's in low position. This allows the board to be set in USB in application programming mode. And finally, program switch must be set to the right. This will set the board to be in the programming mode. For those of you who need further information about the various features and settings of the evaluation board, links to more information and data sheets will be provided at the end of this presentation, but for now we will continue. We are now ready to connect our target to the host. Upon connection, you should see two LEDs light up. One is the power LED and another one is the programming mode LED, which indicate that we are in the programming mode. Also notice that analog input channel 13, which is mapped to pin C3, is now connected to the onboard potentiometer. We can test if our target is properly connected to the host by typing in request product info command at the Matlab command window with USB as the first parameter and name as the second parameter. Upon entering that command, we should get the name of our target, which is FiO Std, if everything is working fine. I will now disconnect the target and the host. If I try to run the same command again, the system gives us a warning. So if we connect the target and the host again and run the same command, we should get the same correct response. If you happen to forget commands to use, you can always type help rapid STM32 block set, and it will show you a list of most commonly used commands. We are now ready to create our first Simulink model for our target. We will now create a new Simulink model for our target. But first, I recommend that a new folder is created to save all the project files in one place. So right-click here and select new folder. I will call this project ADC HID demo and use that as the name of the subdirectory or the new folder just created. Double clicking on the folder, move us to that directory there. This is important. And to create a new Simulink model, we go to File, New Model. A blank Simulink model will appear. First, we save it as I will use the same name, ADC HID demo, and then save. The next step is important. We must tell Simulink that our model will be using and generating codes for STM32. So go to Simulation, Configuration Parameter, and under Real-Time Workshop, select System Target File by browsing and select Rapid STM32 target. Click OK. Under Rapid STM32 option, at the moment our target is FiO Standard and the cross compiler is RealView MDK. Click OK and save that once. Next, we will bring in all the required blocks to create our model. We can do that by opening up Library browser, go to Rapid STM32 block set. Our model require at least the system setup, clock, and sysdig under device configuration. So just select that block, drag and drop it in the model. Since we are using FiO Evaluation Board, we can automatically compile and download the generated source code in one process. Next, go to On-Chip Peripheral, drag the ADC configuration block to the target model and the USB HID send block. Save that once. So most of the time we need to configure this block to match our situation. In this case, we want to read channel 16 and 13 of the analog input, and we want the resolution to be 12 bits, and output from the block as volts using single precision format. The sample time is 10 milliseconds or 10 Hertz. If you press help, you can see which pin is mapped to which analog input channel. There, the on-chip temperature sensor is channel 16 and the ADC in channel 13 is 13, which is mapped to pin C3. And then close that for now. Click OK. Next, we will configure our HID send block. Double clicking on it. Since we are going to be transmitting to single precision data, so just type in to singles, and the sample time -1 indicates Simulink that just inherit the sample time from the source block that is connected to this block. So in this case, when we connect the ADC to HID send block, it will use the same sample time as the ADC block. And we connect our block together like so. Now, just save that once more. We need to update our system model twice. The first time, you can see changes in the color of the system model. Each color represents the sample time of the model. You can use Ctrl+J hotkey to display which color represents which sample time. So it is quite simple to have multi-rate in Simulink model, but all model at the moment has only single rate at 100 Hz. Next, we will have to update the block diagram again because all the sample time is still 0. Once updated, all the sample times of all blocks should display the correct sample time, which is 10 milliseconds there. Then we know that we are ready to proceed with the code generation and the build process. So to build our model, we just go to Tools, Real-Time Workshop, and Build Model, or use the Ctrl+B hotkey. Click OK. And then the build process will proceed from code generation, that is generating the C source code and header files, to calling RealWheel MDK to compile the source code, and finally download the executable to the target. And you can see the process and the progress in the command window there. A new folder will be created with the same name as our Simulink model, ending with _rapidstm32. This is where our source files, both the header files and the source code, is saved. Now you can see the programming process is taking place, and the process is successfully done. Where the target build directory is here, the source code is all there, where you can modify it. So this completes our section for the creating and building the target. Next, we will proceed to create a Simulink model for our host PC.